Hello all, this is Mr. G, and after this video we should be able to use inverse trig functions. So we already know about the basic trig functions, sine, cosine, and tangent, but today in this video we're going to talk about what it means to have the inverse of those trig functions. Now the inverse of those trig functions are called arcsine, arccosine, and arctangent. So arcsine is the inverse of sine, arccosine is the inverse of cosine, and following the pattern, arctangent is the inverse of tangent. Now, on a calculator, these are notated as sine -1, cosine -1, and tangent -1. Now, I'll be honest with you. I hate this notation. I absolutely can't stand it. But why is a story for another video. But just know that whenever I'm doing these problems, I'm never going to write sine -1. I'm always going to write arcsine, arccosine, and arctangent. Let's take a look at the next one. So before we get to our examples, we're going to do some calculator work. Make sure we understand how to use these things. So we're going to start with the sine of 25. So before I do that, I have to make sure I'm in degree mode, excuse me. So I'm going to change this degree, 2 degrees, second quit to get out of there. And now we're ready to type this in. So let's see, sine of 25, what's that going to give us? 0.4226, so we'll round to 423. And the next thing we're going to do is, okay, we're going to find the arcsine of that decimal. So what happens if we give arcsine the decimal that sine of 25 gave us? Well, let's see what happens. Now, to get to arcsine, you have to hit second and then sine. That's at least how you do it on a graphing calculator, TI-84. It might be different on the calculator you have at home. But I'm going to hit second sine to get arcsine, and I'm going to type 0.423. And we get 25.02. Which sounds kind of familiar. That's pretty close to the 25 degrees, which actually makes sense because remember, the word inverse means undo. So the sine of 25 gave us this decimal, and then the arcsine of that decimal gave us almost back the 25. Now you might be thinking, why wasn't it exactly 25? Why is this 0.02 there? Well, that's because the sine of 25 isn't exactly equal to 0.423. We rounded there. Let's do another one. So now we have arctangent of tangent of 56. Now we got to use our order of operations here. We always start inside the parentheses. So we're not going to do anything with the arctangent outside. We're going to start inside with the tangent of 56. So the arctangent just comes along for the ride. Arctangent of, let's type in tangent 56. We can clear that out. Tangent 56, let's see what we get. 1.483 it rounds to. 1.483. Now let's just find the arctangent. So we hit second and tangent to get arctangent in our calculator. Then I type 1.483 and we get 56.008 it'll round to. Again, very close to that 56 we started with. We just didn't get the exact same thing because we rounded. One more. Arccosine of cosine 23. Okay, I got to be honest with you. I've had enough of this. We already know what the answer is going to be. Here, where were we? Here, the sine of 25 gave us a decimal. The arcsine of that decimal gave us essentially 25 again. Here, tangent of 56 gave us a decimal, and then the arctangent of that decimal gave us essentially this 56 back. So the arccosine of cosine 23, that's just going to be 23 degrees. And if you don't believe me, we can type that into a calculator. Second cosine for arccosine of cosine 23. We can close the parentheses if we want. Hit enter, and we get 23 back. So essentially what arccosine and cosine do is they cancel each other out. They undo one another. What we have here is another example of inverse operations. Just like addition and subtraction undo each other, or multiplication or division, or a power of 2 and a square root, they cancel each other out. All right, now that we got that out of the way, let's actually apply this to some problems where we're finding missing parts in a right triangle. So in example 1, we have to find the value of x. And this looks very similar to what we saw in our previous video lessons, but the big difference here is that instead of looking for a missing side, we're looking for a missing angle. But I mean, it's still a right triangle, so we can still use SohCahToa. We can use our right triangle trigonometry, sine, cosine, and tangent. Let's figure this out. So we know we're going to focus on x because that's the angle that we're looking for. And let's see, 14 is the hypotenuse, 6 would be opposite, and the blank side is adjacent, but we don't really need the adjacent here because it's blank. It's not going to be helpful. So we want opposite and hypotenuse. So where would that be? Which part of SohCahToa? Oh, right there. S-O-A. It's got the O and it's got the H we're looking for. So S stands for sine. Where will I put my word? We'll put it right here. So it's going to be sine. That's the ratio that's actually going to help us. And it's going to be sine of what? Normally it's sine of a number, but here they don't give us the angle. So we're going to make it sine of x degrees. Sine of x degrees equals, and it's always a sine, cosine, or tangent of the angle equals the ratio. So next is the ratio, which is opposite over hypotenuse. So it's 6 over 14. So writing the equation was pretty much the same, but what was different, or what's different now rather, is that the x is not with the division. Like normally we would multiply by the denominator of 14 to get x by itself, but that actually isn't going to help us get x by itself. So we don't want to do that here because x is not with the division. This division is totally cool. There's no variable there, so we're just going to leave that alone. What we need to get rid of is this sine. Sine is with x. Sine is what we have to get rid of to get x by itself. And what undoes sine? What's the inverse of sine? Arc sine. So we're going to take the arc sine of sine of x degrees. And we're going to set that equal to, well, let's think. We did the arc sine of one side on one side of the equation, so we have to do the same thing on the other. So we just put arc sine of, what did we have on that side? Just 6 over 14. And on the left side, this cancels out, and we're just left with x degrees equals, now we just plug that into a calculator, second sine for arc sine, and 6 over 14, we get 25.38. 25.38 degrees it rounds to, and we are finished. We're all done. Now, you could have done this slightly quicker. Like, if you're good enough to look at this and be like, okay, wait a minute, I'm looking for an angle. That means we need one of our arcs, okay? So it's going to be arc, and then sort of think it through. Pick sine, so it's arc sine of the ratio, 6 over 14. If you're good enough to go straight to your answer, that's a good thing. I'm always going to show my work and write the equation just because I feel like it's helpful to always have a pattern. Okay, with these problems, we always start with the equation. But if you're good enough to go straight there, more power to you. Let's take a look at this next one we're doing together. Find the value of theta, this variable, this Greek letter that we usually use to represent angles in math is called theta. But even if you don't know what it's called, it's just a variable. That's what we're looking for. All right, we see it's a right triangle, and we're looking for an angle. That just screams SohCahToa. That screams we need trigonometry for this problem. That's our home base. That's our reference angle. So sine, cosine, or tangent, let's label. The hypotenuse is blank, so we don't need that. That's actually enough to tell us which one we want, but I'm going to keep on labeling. Opposite theta, opposite our angle is 6, and then that means 5 has to be the adjacent leg. So hopefully you see that we want the last part of SohCahToa, the tangent part, because that's got the opposite and the adjacent that we want. So it's going to be tangent. Tangent of the angle, which is theta, equals, and let's think, it's opposite over adjacent, so it's going to be 6 over 5. And then we just ask ourselves, okay, what's with the variable that we have to get rid of? Is it the division? No, no variable with the division, so we do not multiply by the denominator. What we need to get rid of is the tangent. And we can't just divide by tangent, like this isn't tangent times theta. That's not how it works. To get rid of tangent, we use arc tangent. So I'm going to put arc tangent of tangent theta equals, and if we take the arc tangent of the left, we take the arc tangent of the right, which is arc tangent of 6 divided by 5. These two cancel out. We're left with theta on the left equals, and then the calculator comes in. Second tangent for arc tangent, 6 divided by 5. And we get 50.19. 50.19 degrees. And there we go. Just one more. This one I want you to try on your own. So pause the video right here. Come back when you think you have an answer, and we'll see if you got it right. We're going over 3, 2, 1. Let's go. Looking at this, we've got to find x. Let's use SohCahToa. since it's a right triangle, and we're looking for an angle, which is our home base, our reference angle. Let's see. The hypotenuse is 17. Opposite is the blank side, which obviously we're not going to use because there's no information there. And the last one, 8, has to be the adjacent leg, which makes sense. It's right there touching our angle. Oops, let's put that back in. Didn't mean for that to go away. So adjacent and hypotenuse, that's the middle part of SohCahToa. That's got the A and H that we're looking for. So we have to use cosine. It's going to be cosine of the angle, which is x degrees, equals the ratio. Cosine is adjacent over hypotenuse, so it's 8 over 17. And now we just ask ourselves, what's with x we have to get rid of? It's the cosine right here. To get rid of cosine, we use arc cosine, the inverse of cosine. So arc cosine of x degrees equals, and anything we do to one side, we do to the other. So we take the arc cosine of the right side, which is 8 over 17, and these cancel out, and we are just a few calculator buttons away from getting our answer. Second cosine for arc cosine, 8 over 17. We hit enter, and then we get 61.93 degrees. And there we go. All done. Let's make that look a little bit better. That's better. All right, hopefully this made sense. As always, if you have questions, let me know. Enjoy the rest of your day.